Hi, how are
Hey,
you?
I'm doing good. Sorry for the delay. I was on my PC.
No worries. I had same thing happened with me. I didn't know that Twitter doesn't provide, ability to join as a speaker from the web.
Yeah, that's weird. It's my first time on a Twitter space, so apologies.
No worries. I hate, when we have to install apps. I mostly prefer doing it from the web.
Yeah, same.
Yeah. So, hi everyone. My name is Sonia, founder of the Cosmos Ladies. Today we are joined by Aditya from Interchain to discuss about IBC. It's going to be of the format expert explains one concept in 5 levels of difficulty. So we are going to go from the rookie level to an expert level. So I'm sure there is going to be something for everyone. Why don't we start with an introduction? Aditya, would you like to introduce yourself?
Yeah, sure. My name's Adi. I work in the IBC product team as an analyst, and I'm fairly new. I just joined about 4.5 months ago. Um, yeah, and like over the past 2 years, I've in some capacity been involved in like blockchain space. Um, yeah, and I don't know if I'm an expert in IBC, but yeah, I mean, I'll try to explain it as well as I
That's super cool. By the way, how did you get started in Cosmos? What's the backstory behind that?
can. Well, I think like the Cosmos Hub was like one of the initial chains that I was following. Like, I think I got into like distributed systems, like the blockchain space back in 2020, and Cosmos was like always on the top of my radar, and I was working at like service providers within the blockchain space, but I always wanted to like sort of work for a core protocol, like move down the architecture level and like work at a protocol itself. And like I couldn't think of a better place other than to work within the Cosmos ecosystem.
That's cool. And what excites you about Cosmos? There are a lot of other ecosystems as well. So, what do you find special or an individuality in Cosmos?
Well, I think like the Cosmos has like we've taken a bunch of different principles opposed to a lot of other networks within this ecosystem. And as of now, like it seems to be working. And obviously, I'm particularly excited about IBC and like how it's being used in the wild. I mean, it's been live for like a year and a half now, and there's like billions of USD volume flowing through it, like over the past 1 year or so. And it's kind of like this vision of building out an internet of blockchains, aka the interchain. That's sort of like what drives me, and um, yeah, that's probably the thing that excites me the most.
That's nice. That's nice. So now, I will be going to the questions from the rookie level to expert level. So, how would you explain Cosmos and IBC to a person who doesn't know anything about crypto and blockchain?
To someone who doesn't know what blockchains are, I would probably say that a blockchain is essentially a database. So in the sense that this database is not like in one location, but it's distributed or replicated across different computers, and these computers might be in different parts of the world. And as of today, these databases kind of suck at talking to one another, right? Like, for example, I'm sitting in one part of the world and you're sitting in another part of the world, and we're still able to talk to one another. And why can we do that? It's because of the internet, right? And the underlying protocols. And that's the main value proposition of internet. It's because this value can be transferred between people, between communities, irrespective of where they are in the world. Like they don't need to be under the same roof. And so you need this value transfer for like maximum utility and so on. And so like as of today or like prior to IBC launching, like I said, these blockchains weren't really that good at talking to one another. And so what IBC does is, well, first of all, IBC stands for inter-blockchain communication. And in short, what it does is it allows these databases, aka blockchains, to talk to one another, and like each blockchain might be good at doing one thing, but they can't be like siloed off in different places. And you want like the value that one chain gives you, you want to like transfer that across to another chain and like make use of all the value from all these different parts of the chains. And that's exactly what IBC is.
Thanks for explaining. And now moving forward, how we will explain Cosmos and IBC to a person or group of person who has only heard of Bitcoin and Ethereum, but it's quite a crypto rookie.
Right. Yeah. So if you've used Bitcoin, you or like if you've heard of Bitcoin, you probably heard that it's good at doing one thing and one thing only, and it's sort of like this rock, and that's probably what makes it so elegant in the first place. And it can't really do much other than this one thing. And like Bitcoin has no understanding, or like it doesn't know about other blockchains. It just can't like talk to another chain itself. And Ethereum is like this, like there's more stuff going on Ethereum. There's like applications built on top of it. You can like take out loans, you can lend to like other people, you can buy NFTs and so on. So like there's a lot of activity going on Ethereum, but obviously like within, given that we're all in like distributed systems, it's all a question of trade-offs. And like Ethereum makes its own trade-offs, right? They have this idea of one massive computer that'll serve 7 billion people in the world. And as I say that, like you probably realize like that's kind of a crazy vision, and like it's not easy to build that out. And Ethereum is like facing some of those issues in terms of scalability and so on. Cosmos, on the other hand, has taken like a completely different direction. In the Cosmos ecosystem, it's more like, okay, so there's all these blockchains, but every single application that can be like a financial application, something for NFTs, something for gaming, and so on. All of these things will have their own dedicated blockchain. And it's not just enough, like I mentioned, it's not just enough to have these chains, but they really need to be able to talk to one another. And that's exactly what IBC does. IBC acts as this connective tissue to connect all these different blockchains and to allow them to transfer value between one another.
That's super detailed. That's cool. By the way, which was the first ecosystem that you got interacted? Was it directly Cosmos or first of all Ethereum?
So I got into blockchains through this concept of ZK snarks, and I think that was initially being implemented. So I kind of had a little bit of a backwards entry into crypto. And ZK snarks was being used on Mina protocol, I think. And then I learned about Bitcoin and then Ethereum. So yeah, it probably wasn't like the conventional entry point into blockchains.
That's quite a journey. And from how long have you been working in the ecosystem?
In Cosmos,
Yeah.
for like 4.5 months now. So I'm fairly
Yeah.
new.
Oh, cool, cool. So, yeah, so I have a question related to this. How we will explain IBC to a person who is, well versed with the other Web3 ecosystems, but doesn't know anything about Cosmos?
Mhm. Um, yeah, so I guess a lot of what was mentioned earlier translates to this one as well, in the sense that, like, if you want to do something, if you want to trade, swap, there's a dedicated blockchain for that. And like, there's all these different chains within the Cosmos ecosystem. Like, Cosmos is not one chain. Cosmos is not just the Cosmos Hub. Cosmos is not just Osmosis, or Cosmos is not just IBC, right? It's like um, this whole ecosystem of a lot of things going on. There's a lot of chains, and there's like other stuff as well, which we can get into. Um, and from a user perspective, maybe like one of the things that would stand out is like user experience, right? Like maybe as a user, you've used Ethereum, you've used Uniswap, and you've seen like the kind of with like when the chain is being used a lot, the how expensive it can get in terms of gas fees and so on. That's like one of the parameters that we optimize for in Cosmos, right? Because when there's an entirely dedicated chain to do one thing, there's like no other applications competing for resources, and that directly translates into a better user experience. Like, and also in terms of IBC as well, like because IBC is built on these blockchains that are quote unquote like fast in terms of finality, and we can get into that later. That also translates into the UX of IBC. Like if you've made an IBC transfer, if you haven't, I highly encourage you. Like you try to send a transfer from like Cosmos Hub to Osmosis or something, like your tokens or NFT or whatever, like gets to the other side in like a matter of 5 seconds. And you don't, as far as I know, you don't really have that within other ecosystems. And again, like IBC at the end of the day is a way for you as a user to like jump from one platform to another, to use all the good features of all these different chains. And like probably something worth noting is that IBC is not just for token transfers, right? Like that's one thing that's talked a lot about bridges today, and people think that it's only about transferring money. But IBC is really for any form of data. Like it's arbitrary message passing, meaning that I can send anything over IBC. That can be an NFT, that can be a token, that can be like Oracle data. And there's like other cool stuff like interchain accounts, interchain security, which we can get to. All of that is like made possible because of IBC.
Yeah, there's a lot more to IVC, and I'm learning a lot of new things today. And so, yeah, moving forward, how would you differentiate between Cosmos and Polkadot? Not from a technical point of view, but more from a user point of view.
Um, well, from a UX perspective, um, I wouldn't really know because I haven't used a lot of parachains, just like very minimally Akala and stuff. And like they've built out cool infrastructure. I mean, I like the Polkadot ecosystem. The parachains are cool. But well, technically, like most of the differences between IBC and like or like the Cosmos ecosystem, Polkadot is like technical differences in terms of like Polkadot's relay chain parachain model, and Cosmos is like completely different. Um, but from a user experience, I'm probably not the best person to answer that because I just like haven't used parachains much. But more on the technical side, I mean, I can like probably talk about that.
Sure, sure. And so, yeah, going to our like original topics, how we will explain Cosmos and IBC to a Web2 developer, or we can say a network engineer who has a very minimal knowledge about Web3.
Um, well, I guess maybe some like an analogy that might transfer from like IBC to the Web2 world is a TCP/IP, right? Like the internet protocols, um, like similar to how TCP, like the internet works, it has a transport layer, meaning that like there's this one layer that's purely responsible for sending data from one point to another. And like it does not care about what that data is. It doesn't do anything to like change the data. It doesn't say what the data needs to be. It just does this one job of sending packets from one place to another. And there's like applications built on top of it, like HTTP for like web pages and like SMTP and so on. And similar to that, IBC was designed with TCP/IP in mind, or like with the Internet Protocol in mind. So similarly, IBC has a transport layer, which is only responsible for sending IBC packets from one chain to another. And there's applications built on top of it, like token transfer is an application, NFT transfer is an application, interchain accounts is an application, and so on. But in terms of like tooling and stuff, like maybe you worked on backend or like distributed system, sorry, like just database systems, which is like not all that different from blockchains. Or maybe you were like a front end developer or something. And at the end of the day, like for when you come to like when you're building in the Cosmos ecosystem, the tools that you need are sort of provided to you. Like as a developer, you don't want to like all you want to do is like build an application, right? You just want to write code to like build out your application, and you want that to be like uh, you want that to give as good a UX as possible, and you don't want to think about like how to replicate this application across different machines, which is essentially what a blockchain is. And so, in terms of developer tooling, like you get Tendermint out of the box, right? Like you can build your application, connect to Tendermint, and Tendermint. So just to give some context, Tendermint is like the consensus engine, which is what will take your application and like split it across all these different computers. And you also have like the software development kit, the Cosmos SDK, which you can use to like build your applications. Um, and what else? And of course, like once you've built your application and once you have your blockchain up and running, you also have a way out of the box to like connect to other chains through IBC. And that's as simple as just like importing the IBC module into your application. Um, so yeah, I hope I answered your question.
Yeah, yeah, that answers very well. Yeah, going to another level. Uh, Before we go to another level, do you have any resources or the documentation that you would like to point out for the people, who are new to this ecosystem and want to learn about IBC?
Yeah, sure. I mean, if you're a developer, you can go to tutorials.cosmos.network. Like there's a bunch of good resources, literally from like A to Z in terms of understanding everything as a beginner to like writing out, like building out your first blockchain. So all of that is given there. There's also like, we've started an interchain developer academy. So you can like, if you have some experience writing like applications in like Golang or Rust or something, you can apply to sort of learn to become like an engineer within the space. But there's also documentation for all of these. So for Cosmos SDK, if you go to ibcprotocol.org, you can see the documentation for IBC. And yeah, I guess you would be able to access all of this from cosmos.network, the website.
This reminds me that the applications for the next cohort are open. So, if
Mhm.
anyone is interested to join, definitely do apply for that. It's a great course, taking you from beginner to an advanced level. So, highly recommended. Yeah, so, moving forward, how we will explain IBC to a person who has experience building cross chain bridges but it's new to IBC.
Right. So I would hope that if you build cross-chain bridges, you come across IBC in some sense, or have maybe even been like influenced by its design. Um, but so there's like different kinds of bridges, right? Like there's so in the case of IBC, it's a natively verified system. We can like get into that. There's also bridges in terms of, let's say a chain A and B wants to talk to another, but there might be like this third chain, chain C, that facilitates interoperability. Um, so in terms of that, like at the end of the day, IBC is like, you can probably boil down IBC to two aspects, which is light clients and relayers. And like building a light client for your chain is probably like the most important thing. And if your chain is a Tendermint-based blockchain, then building the light client is much easier. And so what is a light client? It's essentially a client that can connect to a full node and like download block headers. And in the case of IBC, every chain has a light client of its counterparty chain, and that's how it knows what's going on the other side. Um, but so if you take an example, chain A and chain A has like a light client of chain B, and chain B has a light client of chain A. And so at any given point of time, these two chains know what's going on the other side. But they're not like sending messages directly to one another. Like blockchains kind of suck at this. You need some sort of way to push data into blockchains, right? And that's where relayers come in. Relayers are these off-chain entities that Um, I mean, we can get into like the real depths of this later if you'd like, but on a high level, relays are like looking for IBC messages. When they see something, they pick it up and they like sort of copy paste it onto the other chain. And then the other chain, using like Merkle proofs, can verify that, okay, this thing that happened on the other side is true, and now I can do something based off of that. And so, like, as a builder, as somebody who's building, like, maybe you plan on building like a blockchain on the Cosmos ecosystem using Tendermint, I would say like the most important thing is building a lifeline. And again, if you're using Cosmos SDK along with Tendermint, then you don't need to worry about all these things. It's just like importing one module. It's all like built out for you. But if it's like a completely different chain with a different consensus algorithm, then yeah, like client is like the first step. Um, yeah, and yeah, I guess that would probably be how I explain it.
Yeah. Also, is it possible to connect IBC to Web2 apps?
So theoretically, yes, but we haven't really seen this in practice a lot. So IBC, so light clients are not the only way to connect to blockchains. There's also like Solar machines. So a Solar machine is something without without a consensus algorithm, and that can be like your phone, your laptop, some web server somewhere. Um, and so in that sense, the Solar machine can also technically connect to like Osmosis or something and speak IBC, and you see that. I think the only production ready version of this right now is crypto.com, where like the exchange supports a Solar machine and they mint IBC tokens using the Solar machine and so on. But I don't know if you could use it with a Web2 app. Uh, yeah, that's probably a question for one of our engineers.
Yeah, yeah, this is going to be interesting. I'm looking forward,
Yeah,
what's going to be there in the future.
right.
Um, so yeah, moving forward to our few last questions. How we will explain IBC to a person who already have an high level understanding of Cosmos and IBC,
Mhm.
but wants to learn how the technology works underneath.
Right. Yeah, so I guess I kind of talked about this a little bit in terms of light clients and relays, but sort of just coming back to that and to maybe like double click on that a little bit. So like light clients and relays, they fall into like this transport layer that we talked about. So IBC is divided into the transport layer and the application layer. And the transport layer is only concerned with sending packets. And then the application layer is only concerned with deciding what to do with those packets. And if you again go back to the example of chain A and B, um, when chain A wants to send like an IBC message to chain B, what it really is doing is that it's essentially storing a hash of the packet data in its own state machine. So it's like committing to this message. And IBC has this event emitting system where when you like do something, it events this emit saying, okay, like this is an IBC transaction, this is like a delegation, this is a mint, this is a burn, and so on. And so relayers, which is essentially just software, is they can like monitor for these events. And when they see a send message, when they see an IBC send message, they can query that, and they can deconstruct this hash. Like they ferry the entire packet data, so they can actually see like what's in the IBC packet, and they deposit that into like the receiving chain. And so you might be asking like, okay, but how does this receiving chain actually know without somebody else like telling them that this message is true? So in the case of IBC messages, like what is being passed over, or like what is in this packet data is like it can be boiled down to like three things. One is like the root hash, the consensus state of the application. So the consensus state of chain A's application. There is also a proof, and there's the actual transaction data. And so if you think about this in like a Merkle root set, like a Merkle tree sense, you have the leaves of the tree, right? I'm assuming like people are familiar with Merkle tree. You have like the leaves of the Merkle tree, you have a proof, and you have the root hash. And so Now you can just check to see that this message hashes up to the root hash. And if it does, then you without trusting somebody else can be sure that this message happened. Sorry, this message happened on A, and now B can take some action depending on that, whatever the application logic is. So that's like the core selling point of IBC, right? Like you see a lot of bridges today where, um, for example, there's chain A, chain B, and like chain C is the one that's facilitating communication between these two chains. In that case, like that system is as strong as its weakest link. And so chain A and B might be backed by billions of dollars and maybe it's economically very secure. But if this third chain, the interoperability chain, is like not that strong, then like it's more of a attack vector. Like it's like weaker relative to the other two chains. And so you're also trusting this third chain. But when you use IBC, you're not trusting IBC. You're just trusting, like if you send a message from the Cosmos Hub to Osmosis, you're only trusting the security model or the validator set of Cosmos Hub and Osmosis, but not IBC. So that's why we believe that in terms of trust assumptions, IBC has like perhaps one of the best trust models that exist today.
And how does IBC handle all the chain forks or the block reversing?
Um, so given that we're all on Tendermint here with instant finality, that's like one of the properties, right? Like Cosmos from the beginning has prioritized safety over liveness. So like you can with unless the validator set, unless more than one third of the validator set is Byzantine, then you can be sure that there won't be any forks or like reverts. But just to like answer your question there, if more than one third of the validator set is malicious, then what IBC has like fallback mechanisms. So the light client will immediately shut down if it sees some sort of a misbehavior, right? Like maybe there were two blocks that were signed and there's like if there's like two blocks or like two different kinds of messages that were signed by the validators at the same height, then that's like a reason for the light client to shut down. Or like if it breaks time monotonicity and stuff like that, um, essentially the light client just shuts down and then you need a governance to reactivate it again.
Do you think that IBC can evolve to not use relayers but use some built in chain mechanisms?
Um, I'm not exactly sure. I haven't thought about this a lot, but I have like heard conversations about a future where there might not really be relayers, and there's like somehow through consensus, all of these messages are like just relayed from one chain to another. But that's probably more than 5 years ahead, like 5 years off. So I haven't given much thought to it. If you have any ideas, I'm open to it. I'm all ears.
Yeah. Maybe would you like to throw some shadow on the future roadmap of IBC?
Yeah, sure. So one of like the main engineering priorities right now. So just for some clarity, like I work on the product side, not on the implementation side of things. But one of the like interchain accounts is like it's in production, but you still need like a controller account module that needs to be built out. So that's like one priority. So interchain accounts, if you're not familiar, is essentially a way for you as a user to sit on one chain and just like control another account on another chain without having to leave the first chain and so on. So it's just like a better UX. Um, but there's also other cool stuff that was launched. So like recently with the V4 release, we released fee middleware. So fee middleware, just to back up here, as of today, relayers, they operate completely based on like altruistic reasons. Nobody's like the users are not paying for relayers to send messages. It's more like teams that are paying for relayers or like funding from other mechanisms and so on. So what the fee middleware does is it's basically a on-chain mechanism for relayers to be funded, and we think that's important for like the interchain to scale because today it's like only 50 chains, but in a scenario where there's like 500,000 and 500,000 chains connected over IBC, we need relayers to be incentivized properly, given that like they're so key to the liveness of the protocol. And so that was released, but it can only be used on new channels. And so that's another thing. So channel upgradability is another thing that should be released Q4 this year. So channel upgradability essentially allows you to upgrade channels without having to open a completely new channel. So like you might have a lot of liquidity and network effects and fungibility and stuff on one channel, and if you open a completely different channel for something, then you lose all of that accumulated state. And so that's what channel upgradability is for. And then, of course, like interchain security will be launching later this year or early next year. And IBC is like a key part of that as well. Yeah, so like there's a bunch of stuff going on.
That's cool. And how does IBC work with the interchain security? Does the parent child still rely on the light client with the child chain for the trust?
So I haven't looked into this much, but essentially how IBC is used is that um, um, so for in the case of interchain security, there's this consumer chain and like the Cosmos Hub, for example, that's providing security, the provider chain. And so for the consumer chain to know its validator set at any given point of time, like at a certain block height or so on, you need that information to be transferred across in some way from the hub. And that's essentially what IBC does.
Cool. Okay, coming to our last question, can you explain how the architecture works of IBC to communicate between the two chains? And feel free to get technical as required.
Um, yeah, so I guess we kind of touched about this. Are you talking about like proof verification and stuff?
Yeah.
Yeah, so this is essentially like what we discussed earlier. Um, so IBC at the root of it, like 95% of IBC being used today is through lightlines. Um, and like, so IBC without having to trust any other chain can still like verify messages and stuff, and that's through lightlines. Um, and a light client is essentially just an algorithm to keep track of what's going on in like another chain. So if there's the Cosmos Hub and Osmosis, and Cosmos Hub wants to send 10 atoms to Osmosis, Cosmos Hub will like sort of store a IBC packet in its state machine, um, saying that 10 atom needs to be sent to like Osmosis. And essentially it's storing like a hash of the packet data, not the entire packet data. And with the event emitting system that IBC uses, relayers can essentially like query for these events that are emitted. They take the entire packet. So like relayers are kind of like a daemon essentially, or just like some software to replicate messages from one place to another. And essentially what it's just doing is like querying for these messages and then like copying it and sort of pasting it onto the destination chain. And so at the core of it, like if you go into the code base, and I personally was just like learning this as well recently, there's something called a client state and a consensus state. And like within this consensus state struct, there's a root hash of the application. So in the case of Cosmos Hub, at any given point of time, at any given height, it is at a certain state, and that can be hashed into like a root hash. So and then, of course, there's this actual packet data of 10 atoms being transferred from the hub to Osmosis, and you can think of that like as the leaves of the Merkle tree. And in the case of IBC, there's this ICS 23. ICS stands for interchain standards, and that's essentially a way for all IBC chains to decide upon where something is stored in like the KV store, like key value store. And so when Osmosis gets this message, it knows exactly where to check in terms of where the hub stored this packet data. And so that's essentially like the path of the Merkle tree. And so if you think about it now, you have the leaves, you have the path, you have the Merkle root, the root hash, and you just like ensure that this hash, like the leaves hashes up to the root of the tree. And yeah, that's essentially how packets are verified. And then of course, like once a message is sent from hub to osmosis, osmosis will send back an acknowledgement saying, hey, I got this message, and you don't have to like store the receipt on your state machine anymore. You can like do that. So it's kind of like this communication that goes on. And from a application, like from an application developer perspective, you really only need to concern yourself with like clients, and there's also another layer of abstraction called channels. So a channel is basically this conduit for different modules to send messages between one another. And you can think of a module as like a smart contract or like a batch of code that executes some function. And that's from a developer perspective, that's all you need to concern yourself with, that there's more layers of abstractions like connections and ports and all of that kind of stuff, but you don't really need to um, look into that much.
That's cool. Thank you so much, Aditya, explaining it from a technical point of view. I really appreciate it. And I am sure, everything got something to look upon and read. If you have anything else you want to share, feel free to.
Oh, I probably didn't mention that like there's also like cosmosm is another big thing. So if you're like a smart contract developer, like if you know Rust, you can also like write contracts in Rust now, and a lot of chains support this. There's like smart contract platform, like dedicated chains like Juno, and Neutron is another one that's launching with interchain security. But maybe you're also like a Solidity developer, in which case we have EVM that's like built on Tendermint, and it's called Evmos. The chain is called Evmos. And so it's kind of like giving you the best of both worlds. Like you get Tendermint as a consensus engine, but you also have all the tools that you use to like build contracts in Solidity, and you have IBC to like speak to other chains. So there's this diverse options that's available to you as like a developer, I guess.
Yeah, there's a lot to explore. And, I'm sure with the time we have a better discoverability about the Cosmos ecosystem. So, rooting for that. And yeah, thank you so much once again. I really appreciate for you joining, and I'm sure we'll get to do another Twitter space soon.
Yeah, thank you so much. Thanks for having me.
Alrighty. Thank you so much.